Okay, this is the second revision video. This is Defence Against Infectious Disease. This is B1 Chapter 2. So the key things you need to be aware of is that pathogens, and it's this key term here, are microorganisms that cause infectious disease. Okay, so this would be things like your bacteria, your viruses. There are good bacteria as well, so it's important that we distinguish that the pathogen is something that causes an infectious disease. Bacteria and viruses can then reproduce really rapidly and produce something called toxins, okay, and that will make us feel really poorly quite quickly. Viruses are slightly different to bacteria in the fact that they live in our cells though, so we can't attack those with antibiotics or kill them, otherwise we'd end up killing our cells instead. Okay, so that would be an issue. So here we can see that they live inside the cell, so they are slightly different to bacteria in that way. So when we look at defence, how we defend our bodies then against this, we are looking primarily, start of all, at white blood cells. Okay, and it's those which we produce inside our body which help us defend against disease. And they do a number of things. They can ingest pathogens, which means engulf, okay, don't use the word eat because they're not living. Produce antibodies, okay, and that they are specific to the disease in which they are fighting. So we have to have the right antibody. In some cases we don't, so we can't fight the disease or the pathogen, and then we'll become poorly. And we could have some white blood cells which can produce antitoxins, which counteract the toxin that's produced that's made us feel really quite poorly. Okay. Semmelweis is a doctor you need to be aware of, that he was the doctor that realised the importance of hand washing, which seems obvious to us now, but prior to this, the doctors did not know that they needed to wash their hands in between patients. So some of the exam questions you'll see show you two wards in hospital, one where doctors washed their hands and one where doctors didn't, and you'll see that the rate of deaths on the wards that doctors did not wash their hands is really quite high. They tend to look at maternity wards because they might have gone from the mortuary, from dead bodies, up to maternity where they're then delivering babies. So we've looked at white blood cells, talked about Semmelweis. So if these things aren't working, you need to know about other options that are available when you are poorly. So you may take a painkiller, okay? It's important to know that painkillers relieve the symptoms. They might take away a headache or any sort of feeling of, when you feel poorly, but they don't kill the pathogens. They don't remove the pathogen at all. They just help you feel better while your body's trying to fight it. However, what we can take if we have a bacterial infection is we could take an antibiotic. An antibiotic will help fight bacteria and kill the bacteria. Okay, so that is something that's useful, but it will not kill a virus because they live inside the cells. Don't forget that. However, we have used antibiotics a lot, and because of that, we have now got antibiotic resistant strains, which you need to be aware of. They are bacteria that is resistant to antibiotics, so we cannot use antibiotics to kill them. The example they like to give you is MRSA. Okay, so MRSA is what's called a superbug, and we can't kill it. Okay, it's really difficult. It's very prevalent in hospitals, okay, because obviously that it can infect sick people because their immune system's already low. What happens then is when you take an antibiotic, it kills the non-resistant pathogen. So it goes into your body and fights it. But some of those pathogens will mutate. And it's this word that's really important. It's mentioned in your exam specification. You need to be aware of it. They will mutate at random. And because they have mutated, some of them will now become resistant to the antibiotic and they will survive. So you've now got living inside you pathogens which are resistant to the antibiotic. They will now grow, reproduce and make you feel ill again, but this antibiotic will not treat it. Okay, so that's why this bacteria now becomes antibiotic resistant. If we have all of our bacteria starting to become antibiotic resistant to the antibiotics that we have developed, we're in an issue now where we don't have antibiotics to start killing bacteria, so that becomes a problem. Okay, another preventative measure could be an immunization. That's an injection that you are given, okay, and that's can be called a vaccine. And what does they inject you with? Dead or inactive forms of the pathogen, so it can't cause any issue at all. It's either completely dead, so we can just look at the outside of it and make some antibodies, get our white blood cells to make some antibodies or antitoxins, or it's inactive, so it's alive but it can't do anything, it can't harm us in any way. Our white blood cells then make antibodies because they can see the pathogen, and we now become immune. So if in the future we become infected, we have the right antibodies to destroy that pathogen, so we are safe. Okay, so we can just very quickly produce an antibody and help cure that bacterial infection. Right, the last little bit you need to know on the specification is about growing cultures. So if we wanted to grow some bacteria, so we could test it with an antibiotic in a lab to see if it worked, this is what we would be doing. We'd sterilise everything we use. We'd sterilise the Petri dish, we'd sterilise the inoculating loop that we're going to dip into our sample and spread it onto our Petri dish with. Everything must be sterilised. The reason being is we don't want any contamination with any other bacteria that might be around. So it's really important that we kill off everything and we only put on the bacteria that we want. We need to secure the lid with tape so the Petri dish sticks flat, and again that's so that we don't get any other bacteria coming in from the air. Okay, so it's all about contamination. It's not about anything getting out, it's about things getting in. And if we're to do it in school, we can only incubate at a maximum temperature of 25 degrees. Okay, and that's a question that's come up quite a few times, so it's important to remember that number. If it's been done in industry, it can go slightly higher, but within schools, you are limited to 25 degrees C in which you can incubate. That means grow that sample in a warm temperature. Okay, so that's all you need to know for Chapter 2, B1, Defence Against Infectious Disease.